Hey, what is up? It is Saturday, May 7th, 2022. Happy Saturday. Yeah, and I am ready to go this late Saturday night with another coding problem for you. Coding way into the night and playing and thinking about playing with dominoes. Yeah, so I had a lot going on the last few days with work stuff, so I did miss yesterday. As I said, I'm gonna try to do a problem a day, um, and I'm kind of glad I got this one. I usually pick randomly from the problems that I do every day. And usually easy and medium ones. This one happens to be an easy. But before I get into that, let me just remind you, welcome to Shaft the Algo Man / Coding with Shaft. Name still up for debate. Let me know if you prefer either in each channel. It doesn't matter. It's all about the coding, not about the name, but it could be. It's marketing, right? Anyway, and don't forget to like, subscribe, and comment in the comment section below. Let me know. Hit the bell icon if you want to be notified. Again, I try to do a video every day, and I'm going to be more regular about it in the mornings as I've been for the last several days. So yeah, just show me some love and I'll show you some algorithms. Okay, so this problem is about dominoes. It's called 1128 number of equivalent domino pairs. Okay, well, it's an easy problem, and that's good. So I'm gonna like this problem, right? And just to let you know that for all of these problems, and remind you, I have a discussion that I write up usually before making this video, and I put that discussion in Leetcode. I'll link to it. It's got all the code that I do on my own, really usually without any reference to other Leetcode solutions if I can. And I try to understand the problem so I can explain it to you well, and it's good practice for me and obviously good for you to hear a well thought out explanation. So let's get to it finally. Given a list of dominoes, dominoes of I equals A comma B is equivalent to dominoes of J equals to C comma D if and only if either A equals C and B equals D, or A equals D and B equals C. Okay, that is, one domino can be rotated to be equal to another domino. Return the number of pairs I comma J for which 0 is less than or equal to I is less than J is less than dominoes that length, and dominoes of I is equivalent to dominoes of J, and equivalent is highlighted. Okay, so what we see here is that we have this example where the dominoes have elements 1 comma 2, 2 comma 1, 3 comma 4, and 5 comma 6. And so intuitively we see the answer is 1, and the reason why is that there's one pair of dominoes that essentially, even when rotated, they're basically the same domino, so they are equivalent, and there's one pair. In example 2, we have 1 2 comma 1 2 comma 1 1 comma 1 2 comma 2 2. So we have three pairs. We have two pair. We have three dominoes, right? Okay, 1 2 1 2 and 1 2 that are equal to each other, and you see the answer is 3, but you have to be careful here. Okay, this is talking about pairs of dominoes, right? Not number of equal dominoes. Okay, so how many pairs of equal dominoes or equivalent dominoes do we have? We have one pair here, we have another pair here, and we have another pair here. So therefore we have 3 pairs. Okay, and it's important to remember, because let's have another example. What does this look like? 2 comma 1. Okay, so we have, what are our pairs? So naively you might be tempted to be like, well, 1 2 3 4, right? Okay, well, and you can ignore 1 and 1 and 2 2 because they don't have any equivalents or equals. So we'll say we have, let's just double check, how many pairs do we have? We have 1 2 comma 1 2, the first 1 2. We have the first 1 2 comma, the second 1, 2, and then we have the second 1, 2, comma, the third 1, 2. Okay, just like one, first one, second one, first one, third one, second one, third one. Okay, but remember, we have another one here. And in this case, 1, 2 with 2, 1. Another 1, 2 with 2, 1. Another 1, 2 with 2, 1. And you see where we're going here, right? We have to create pairs of these dominoes. This domino with this domino, this domino with this domino, this domino with this domino. Okay, right? So we simply don't have, it's not the number of dominoes, it's the number of domino pairs. Now we could do, you know, combinatorics, we can do mathematics, we can do essentially permutations, etc. We can do all of that stuff, but an easy way to just do this, right, is to use a map, and I'll show you how to do this. So if we have a hash map, and you'll see what I'm doing here in a minute. What is the domino here? Okay, I'll explain in a second. So I want to use a custom domino object for this map because I want to be able to easily compute in O of 1 time whether a domino is equivalent or whether the domino is equal. And equal and equivalent essentially have different inputs but the same output, right? And so that requires that a string, for example, in a hash map, and this goes a little into how hash maps work, and I might make a video just on that. There's plenty of that out there already, but it's just good to know. We need to, I'll show you how to construct this object in a second, but we need to essentially have the map have an object, and we can do this without a map, but the reason I'm doing this with a map is because without a map we'd have to rearrange these guys and turn it into strings, and that's some computational overhead. And if at some point in another video I'll show you that this is actually quite a bit of overhead to do this kind of stuff. So instead of having to represent these as two as the same, or turn these into the two same objects using extra cycles, we can just have an object which has the ability to recognize these as two of the same things. Okay, so I'll show you what I mean there. Okay, so we want to, getting back to the problem, we want to return the total number of pairs, right? So what we do, for int I equals 0, I less than dominoes I of 0, dominoes I of 1. Okay, so this is, and this is, let's see, sorry, no, what am I doing here? no, we want to get dominoes dot length I plus plus. Sorry, it's a little late tonight. Mine is now we're going to iterate through the list of dominoes, right? And then what we're going to do, we're going to create a domino object, right? I'm going to call that key because this is going to be the key into the map, and I'm going to construct this object later, but you'll see I'm passing in, I'm making another representation of what we already have for dominoes. Okay, so this is basically the same thing as dominoes in this array, but I choose to do it this way. If my map is called pairs, right, because that's all the pairs that exist of equivalent dominoes, and dominoes contains key, all right, if the key is not in the map, we represent it in the map and we put key 0. So this puts the domino in the map, and we want to do that because the next time we see a domino equivalent or a pair, we want to put that value in the map and increment it again. Just to note that we've seen this in the map already, okay? And we want to increment its value, and here's the trick. We add the current number of pairs that we've seen to the total, and by doing this, every time we see a new element, we augment the computation for the key that we've already seen. And it's not that we're counting the number of dominoes, we're counting the number of pairs because we're adding to the total number of pairs of equivalents that we see for a particular key. Just think about this for a bit and it'll make sense based on those examples that I showed you earlier, but that's essentially what we're doing here. Okay, and now let's get to the custom. Well, first let's return the total value. Okay, and now let's get to the cluster, and this is all really mostly for you Java people. Obviously, Python, you have things that you don't have to do this kind of stuff usually, or in many cases. Okay. Python, you don't have to do this stuff in many cases. Okay, but what I'm doing is int a, int b. I'm creating, this is my constructor for my domino object. This dot a equals a, this dot b equals b. So now here's a trick for this thing. Override public. Okay, so when you actually write custom objects, for those of you who aren't familiar, so some of you are familiar with this, so this is just not gonna, this explanation is not gonna matter, but in order to have these equivalents and equal dominoes quickly be able to be pulled out of a map and the map recognize them as equals, you have to override these two methods, equal and equals and hashCode. I'll explain in a second. Let me just write down this here. Okay, so I override hashCode. I override equals. I'll explain equals first. Equals domino. So this is the This is the you know, super method for equals. You have to kind of just do this casting here to a domino object, and I'm going to say that for this equals method, we want this equals method will help us determine, or help a map determine, that the domino is equal to an equivalent domino. And how do I know that, right? Well, a domino will equal another domino because this is the other we're using this to compare to another domino. Will equal another domino if obviously the A and the B are the same, right? Domino.b, okay. Or what other case? Well, according to the original conditions, if A equals D and B equals C. So if the dominoes opposing values are equal, but both of the opposing values have to be equal to the other opposing value, right? So B equals domino.A. Okay, and if you're not getting this, just think about this a second. I'm just saying that the domino, to be equal to this other domino, has to have its numbers 1 and 2, like 1 and 2, 1, 2 equals 1, 2. All right, and also 1, 2 equals / is equivalent to 2, 1. Okay, and that's all I'm saying here. A is equal to B of the other, B is equal to A of the other for the equivalent case, A is equal to A of the other, and B is equal to B of the other for the equivalent case. Okay, now the hash code, is written this way, right? This looks a little arbitrary if you've never seen this before, but the point of the hash code is that it is essentially specifying a unique location based on the numbers, unique location in memory based on inputs that you've supplied to the object. So essentially the requirement of the hash code is that in order for two objects to be equal, right, as far as a hash map is concerned, to be considered as equal keys in the hash map, they have to have this hash code equal. Now, how can we ensure this? Well, we ensure this based on the parameters that we get in, right? So A and B, right? A and B, we want them to be a function of A and B such that these are commutative. So A and B, we want something that has A and B equal to BA. And how can we ensure that? Well, this is a pretty easy way to do that, because if you switch, this is the commutative property, A times 31 plus B times 31, and if B is equal to A, it'll be B times 31 plus A times 31. That ensures that these two are equal. And why 31? Because 31 is a large number that's less than 5 bits, and it's essentially saying that there's not too many other numbers which will really cause these two things to be equal, right? Like I mean, you could get so-called hash collisions, so to speak, but in the case as a function of the input, read up on hash maps a little bit, this is relatively safe for the context of this problem. Okay, just a little bit more complex. It's not cryptographically or super uniquely safe, but you know, we just need to pass this problem. So let's see if this works. Okay, accepted. And there you go, accepted, and a pretty good runtime. Now I want to show you what you see. Look at the runtimes for the other times that I've run this problem. Let's try one of the slower ones, right? What was the solution there? And take a look what I did. It's similar, but I didn't use a custom object. All I did was I swapped the domino pairs, right, and just sorted them. You know, I didn't have to sort them. I could have just quickly sorted. This is not the limiting, this is not the only limiting time sink right here. Just doing the string conversion here is a time sink, and converting it to a key, and then adding an array list and all that. Instead of that, we do let the hash map do all the work of telling if something is equivalent based on the hash code, right? And that saves a ton of work in these 4 steps, right? Okay, so there's other ways to do that, obviously, but anyway, yeah, so that's the problem. I have the solution up. I'll post it to my Twitter for if you're coming from that, or the description in this channel. And yeah, let me know what you think. That's a long video, but I think it was worth it. I will see you next time.